Let's look at what we call the percent proportion. What this involves is solving essentially for a variable when it's based on a proportion and part of it's a percent. So the main concept or idea in this is that you have a partial taken from a total. That's actually what a percent is because it's the amount of 100 over 100. So for instance, something like 1 over 4, we know that if we were to multiply top and bottom by 25, we would get 25 over 100. And 25 out of 100 is 25%. In between that, we could make that into a decimal, which would be 0.25. And the way that you make a percent is to move the decimal twice and then put the percent sign. So if we looked at this, I say percent, but I should say the number that makes into a percent. So in this kind of an example would be like 25 over here. So 1 over 4 would equal 25 over 100. All right, let's, however, look at another example here. This one where it's 3 over 20 equals a percent over 100. So there are two methods to look at doing this. Let's take a look at the first one. Right? And what this one is, okay, actually, I guess you'd say there's three methods. Let's do one that I don't show on here first. Notice that on the bottom, the 20 can become 100 by multiplying by 5. If we therefore do the same thing on top, so that we're multiplying by 5 over 5, or 1, that would give us a 15 here, which would make 15 over 100, or 15%. So let's take a look at this. In a way, what I just did here is the same as this. Change the first fraction so the denominator is 100. So the 20 can become 100 by multiplying by 5. And so 5 over 5 is 1, and that's sort of what I was talking about up here, but now this shows it as the idea of changing this one to 100 here. So if we have 3 over 100, and then or 3 over 20, and the 20 becomes 100, then the 3 has to become a 15 because of multiplying by 5. The other way to do it, especially if you have numbers that don't work this way, well, right now, let's look at this. We can do this cross multiplying. You can do that when you have an equal sign, which is what we're looking at here. All right. Yeah, the equal sign there, make it look like a little butterfly. We cross multiply, so it's 20 times x equals 300, and then divide by the 20 to isolate the x, and then keep dividing and we get 15. That becomes more useful when you cannot change the 20 into 100. This one's relatively easy to see. Oh, multiply by 5, so we can multiply by 5 here to get 15. So in this case, this one's a little bit of an easier method. This one's probably easier to remember because you don't have to think too hard about what to do until you get down to over here where you're dividing in order to reduce it down to its lowest amount. Okay. Here on this one, simply divide. The third method essentially is 3 divided by 20 comes to 0.15, and then they move the decimal point twice that way, and then you can make it into a percent. Let's take a look at a word problem where we will be able to play with it and do some things with it. We're going to change this into a percent proportion if possible. So back to the original main key thought, I guess I'll put that in red, is that what we have is the partial divided by the total. And for 32 out of 48 people, that means 32 is the part and 48 is the total. So that means 32, like that, so it's 32 and 48. And we want to know what percent that is, what amount, what over 100 it would be. So we can do the long hard way with this of cross multiplying. I say long hard way because we've got pretty big numbers there to deal with. So I can do 48x by multiplying these two and then multiplying these two equals 3,200. It would be much, much easier for me if instead I first looked at these two and if I reduced them. In this particular case, if I divided, well, let's see, look at 32 and 48, 2 goes into both of them. So does 4. So does 8. No, 8 goes on 36. No, how about 12? No. Wait a minute, looks like 16. If I divide that by 16, I would get a 2. And if I divide this by 16, I'd get a 3. So what I really have is 2 over 3 equals x over 100. So notice what I did is I thought about different numbers to see what numbers would work with this, the larger the possible. For those who are not quite sure of that, look over here. And one way that you can reduce numbers is simply start with what you can see is easy here. Let's divide them both by 2. That would give me 16 over 24. Now here I can divide by 2 again, but I also know that both of these can be divided by 4. So if I divide both of those by 4, I would get 4 over 6. And now here I can divide again by 2s, and that would give me 4 divided by 2 is 2, and 6 divided by 2 is 3. So I can do it in steps like this, or I can do it all at one time if I recognize that it's a 16 total. It doesn't matter as long as if you can get it to 2 over 3, then cross multiplying becomes much easier. Oops, let's get those zeros back. So I get 3x equals 200, and then I divide by 3. And so when I divide by 3, I'm going to get an approximate answer of 66.66666 that it just continues to repeat. At some point, I have to make it a 7. It's usually best to do that right up at, say, the tenths or the hundredths place. But we have to use the approximate symbol for that. We can actually approximate that to the ones place and call it 67. Well, it depends on how detailed you want to get. If I don't tell you how detailed to get, then you can choose. This one would not make sense because it's just too far. We don't need it. This would be a good answer, and this would be a good answer. You could accept either. In this case, I'm going to say that x is approximately 67. Or actually, that's not the best answer because it's what percentage own pets. So I would have to say approximately, let's see how much space do I have here. I'll do it right down here. The better answer is to say approximately 67% own pets. That is the best answer. I could have used the approximate symbol, but I'd have to say something like own pets in there in order to make it a reasonable answer to actually answer that question. So this question shows a few steps to do that make some sense, how to set it up, and mainly that you have a partial out of a total. Now, on the next one, right, what percent of 80 is 62? Let's talk about how to determine the partial and the total, because we know we're going to have the part up here and the total down here. And if we knew the percent, we put that in here. But that's what we want to find out is what percent. So the key here is remembering that the word of means times and is means equal. Okay, so it's a percent times 80. So it's some percent times 80 is equal to 62. If I were to divide by 80, I would get that x equals 62 over 80. And notice now that we have a top and a bottom because we've isolated the x. So I can even think of this as x over 100 because I'd move the decimal later. I'm not going to do that yet. Instead, I'm going to tell you that whenever you see of, then the next number is the total. So the word of is your indicator that the next number is the total. And when it's equal to a number, this is the partial. That's if you see this format. Okay. So you could think of this as one of the way of help. Let's say 10% of 50 equals or is 5. Doesn't it make sense that 10%, a partial amount of a total is a smaller amount? Or in this case, not as smaller, but it's out of that. If I did something like 200% of 50, then I'd actually be doubling it, and the answer would be 100. But let's not go there yet. Let's think about the fact that the partial is 62, and then the total is 80. Okay, now we need to make it into 100. Okay, so if we have 62 over 80, we need to start playing with that. You can put it in a calculator to get the decimal. And if we did that, by the way, if we put it in the calculator, you would have 0.775, and you would move the decimal place over twice, and then you would say, well, then you would say 77.5. So it's 77.5%. Oh, I think I meant to do, let me rewrite that, because what I'm saying, really wanted to do is say, oh, here is the percent proportion. And then what we would do is 62 over 80 is equal to 0.775, although that's what that comes to. Then move the decimal twice, and we get 77.5%. If you're not using a calculator, you would need to do 62 over 80. Let's make that easier and better to see. I would divide by 2, so I get 31 over 40. Ooh, that's still tough. I'm going to have to do some long division here. So it's definitely easier in this case to use the calculator to get that number. Okay, so 0.775. And I am going to mark that. I actually like to put the final correct answer or something in a little yellow box here, or yellow it. Bring your attention to it very quickly and immediately. And these others don't have that same need. All right, let's look at another type of the problem. Here's one now where we know what the percent is, and because this is the word of, we know that 80 is the total. Equals what number? Well, this will be the partial. This is the one we don't know. So I'm going to say X over the total and 77.5 over 100. That looks familiar. We know from the last problem that that should be a 62. So let's see if we can get that 62. So in this case here, we are going to cross multiply. 100x equals 80 times 77.5. There's definitely a case where the calculator would be helpful, and so you use it. Times 77.5. Okay. And if you multiply that, put that in the calculator, you would actually get, let's see, with the decimal there, 7.5. Oh, and then we divide by 100. Divide both sides by 100. Because if I did just this part now, I would get 6,200, which is why I have to have dividing by the 100, so the zeros will cancel out. And so we get what I would fill in here. Actually, I don't even really need that part here because the cross multiplying is the easier one. We can't easily make the 80 into 100. So we'll do the cross multiplying. So the actual answer is 62. Since it's not a application word problem, we don't need to state it in a sentence or a phrase. All right. And I think that ends it for this part. Okay, there is more in this section, but these are the main things that I wanted to focus on so you can see how to think about it when you have this kind of a format, and remember what of means and what is means. of the total and is the partial amount, the percentage. Okay. And we did the same thing here. We didn't know the percent. And this one where it was a word type problem, which is still the same exact kind of thing of having a partial over a total. Okay. I hope that helps with understanding how to use these proportions.